So what are quadratic functions and what do we need to know about them? So we're just going to start with like focusing on the graphs, and then from the graphs, what things you need to know about quadratic functions. So first things first, the quadratic function is anything that looks like this curve here. So the curve can be wider, it can be skinnier, it can be flipped upside down. The reason this line curves is because of this x squared right here. So x to the second power, anytime you see x to the second power, if that's in the equation, then we're going to call that a quadratic function. So the main thing here to know is I can add things to this x squared. So I can put numbers in front, I can put numbers behind. But if the highest degree, so like if the highest exponent in the equation is a 2, then the line's going to curve. And we call that quadratic. So quad, think of like 4, like a square. Sometimes we'll say x to the second power is x squared. So quadratics are just x to the second power. I'm going to show you on Desmos real quick what that could look like. So the reason we call this a parent function, so think about your parents, like you came from your parents, right? So this is like the most basic original version of a quadratic function. It's just y equals x squared, and it just curves. I can make that flip by adding a negative, so now the line goes down. I can take away the negative, I can do like a 5, and notice when I do that, it gets skinnier, so it starts to move up faster, right? I can put a small number in front of it, like a 0.1, and it's going to get wider, right? So I can do 0.05, and it gets even wider, right? I can also add things after it. So I can say plus 5, and I just jumped up, right? So I moved up 5 spaces. I could say x squared minus 10, and it jumps down, right? So by adding numbers, it's just going to move the curve around. It can make it wide, it can make it skinny, it can flip it. I could even say like y equals x squared minus 2x, right? And notice it kind of moves. I could do 10x, and it kind of moves even more. And so these changes that you can do to the parent function, right, the basic function, are going to be things that we look at gradually over the next month. But for now, we just need to focus on the starting point. So y equals x squared. If I add specific points to that, you'll notice a little pattern, right? So if I look over here at the table, right, you should see similar numbers for the negatives and the positives, right? Well, think about why that is. What are we doing to the x? If I say x times x, what that means for negative 4 is if I said negative 4 times negative 4, I would get positive 16. So negative times a negative, so if we look on the left side, those are the negatives. Notice the line is still going up. So the y is still positive, right? So negative times a negative makes a positive. Negative 3 times negative 3 makes positive 9. Negative 4 times negative 4 makes positive 16. So the left side is going up even though the x's are negative, because a negative times a negative makes a positive. If I multiply x by itself on the right side, the line still goes up because 1 times 1 makes 1, 2 times 2 makes 4, 3 times 3 makes 9, and 4 times 4 makes 16, right? So the reason quadratics look like they do, the reason they move up fast on both sides, is because the negatives turn into positives and the positives stay positive. So if we were to look at a positive quadratic function, so positive just means that the x is squared and there's no negative in front. So it's just going to be a curve that bends up. There are just a few things you need to know about this graph. So we'll start at the beginning. So at the bottom here, you see a little point. So at the tip of the curve, so vertex is what that's called. And watch what happens. So the vertex is that little dot at the bottom of the curve. So it's the furthest down you can go. When the curve is bending up, the vertex is just this little tip here at the end. Right, so in this case, that's the minimum. It's the lowest y you can have. From there, we can kind of determine the axis of symmetry. So if you think about that word symmetry, it just means same on both sides, right? If we drew a line where x is at 2, so notice that 2 is just the same number as the vertex, it basically cuts the curve down the middle, right? So the axis of symmetry is x equals 2. And then you'll notice 2 points. So these are the points where we cross the x-axis. We'll sometimes call those x-intercepts, zeros, or solutions. So all of these words mean the same thing. So it's just what is x when y is 0? What is x where y is 0? And you notice because it's a curve, right, it crosses the x-axis 2 times. So it has 2 x-intercepts, or 2 zeros. Finally, and this one's kind of less important, but it's something we've talked about with other types of functions. So the y-intercept is just where does the curve cross the y-axis, right? So notice x is 0. What is the y number? -12. If you know this about graphs, then you're good. So they'll ask you questions like, where's the y-intercept? Where are the solutions? Where's the vertex? If you can do those questions, those types of questions, then you understand quadratic graphs. The layers that we're going to add in as you get older, and just watch here, we can talk about different forms of equations. So if you type this into Desmos here, you'll get this graph. We call that standard form, right? And the standard form just shows us the y-intercept. That's pretty much all it's useful for. Whereas if we change the form, so if we kind of move numbers around and change their values, right? These equations here will give you the same graph as the standard form equation. So all we've done is we've just moved numbers around. The nice thing about vertex form is that it shows us where the vertex is. So if you notice the numbers here, 2 and -16, look very similar to this -2 and -16. And then we were doing factoring before we left for break. So this +2 -6, if you notice, match up with the -2 and the +6 here. So it's just the opposites, right? And so we'll talk more about why that is as we get further into the unit. But for now, just know like there's different ways you can write this. The main thing is, can you identify the key features of the graph? So let's just look at a negative and then we're good. So on a negative function that's quadratic, right? The big thing to notice is that this -x² is right here in the equation. So whenever you do that to the x², it's going to flip the graph and it's going to go upside down. So instead of the vertex being a minimum, now it's the topmost point, so the maximum, right? So it's like the top of a mountain. We're still looking for that dot, but just imagine if I took that V in vertex and flipped it upside down, right? So that just means that it's negative. And it almost kind of looks to like an upside down, like this here looks like a lowercase n, right? So an n is negative, the vertex is still at the tip, right? So in this case, the vertex is -3, 2.25. If I were to cut the graph in half, it would be at that -3.5 line, right? So the axis of symmetry is just x equals -3.5. And then our x-intercepts are just where does the curve cross the x-axis, right? The most important thing to know is that these can also just be called zeros or solutions. And then the y-intercept is just where it crosses the y-axis. So it crosses at -10. Standard form is going to show us that -10. The other forms, so vertex form, is going to show us the numbers that are important for finding that point at the top of the quadratic. And then the factored form is going to look very similar to the solutions that we have here, right? So if you remember before break, right, we were taking things that looked like the standard form and we were factoring them down to this green here, this factored form. The reason we were doing that was to find solutions, right? So that's going to be a big part of your math that you do as you get older. But for now, just know, if you can read the graph, you have a very solid foundation for the work we're going to do for the rest of this month.